well, it goes back to the law of inertia, which was basically a discovery of Galileo, but it was then formalized really by Descartes, who had a big influence on Newton. So Newton realized that you could explain things wonderfully if you had the idea of the law of inertia. So the law of inertia says that if an object is left to itself, nothing is acting on it, it will either stay at rest in space or move uniformly in a straight line forever. And Newton realized that he could explain a tremendous number of things by combining this very fundamental law of the law of inertia with the idea that there are forces which deflect objects from this motion. And in particular, that you could understand how the planets are going around the sun, because they have a tendency to go forwards, but the sun is pulling them towards it. So he needed a precise mathematical framework in which to express that idea. Now, what Descartes had tried to do and Newton succeeded in doing was copying the axiomatic framework of geometry that Euclid had created nearly 2,000 years earlier. So he wanted to have an axiomatic system. So this beautiful uniformity of space, like a perfect translucent block of ice or something, was just what he wanted. And then you could have this idea of particles moving uniformly in it. Now, Leibniz, I think, was much closer to the truth, because if you stop and think about it, you couldn't say anything meaningful if there wasn't a lot of variety in the world. So Leibniz said, no, the reality is not smooth uniformity, but is structure, is shape, is variety. I think I'm feeling somewhere I read that he wrote just a very small part of his writings is in German, but I've never managed to find the place again. But if he didn't say it, he easily could have done. It's something along the lines that variety is positive reality. Without variety, you couldn't say anything. And it's perfectly clear you're watching me, the viewers are watching me. You know, if they can't see my hands and see my face changing or hear the different tones in my voice, there's no communication at all. There's nothing. So uniformity is actually nothing, according to Leibniz. But for Newton, it was everything. And in fact, he thought he'd discovered the anatomy of God. He thought it's absolute, for which he had good evidence, because his theory worked so well. But he called it the sensorium of God. And I say he thought he'd discovered the anatomy of God. So it's very interesting. If you look at great figures in science, my estimate, this is a rough one, that about 70 to 80% of the great scientists are very content to think of things in terms, to start from uniformity and explain things in terms of uniformity. And then you get the odd ones out, and they are above all Leibniz and my great hero Ernst Mach from the second half of the 19th century, who go in the opposite direction and say that you can't do anything without variety, and it's all about how differently structured things are related to each other. And when I read Leibniz, I'd already developed the key ideas of my thing, but it made absolutely huge impact on me, particularly 2 or 3 sentences in his monadology. He says that every real thing has infinitely many attributes, infinitely many. To describe a real thing, you have to describe all its attributes, all its properties. And in the process of doing it, you finish up describing the whole universe from the point of view of that person. That's his notion of the contingent notion, or it's also called the actual Adam. To describe Adam, you have to say he was a man who lived in the Garden of Eden and so forth. But there may have been more more men called Adam. There may have been more very beautiful gardens in which live. And then you finish up by describing the whole universe. And so Leibniz was convinced that the real things in the world are sentient beings and each of them is a view of the world from their own point of view. So there's just, he talks about, it's like the views of a town seen in perspective from different points of view. And so you have this notion of a richly structured thing, which is the universe, and each different view of it is actually one of us, or some animal, or things. And it's a fascinating philosophy. He says that this is the way in which the greatest variety, compatible with the simplest laws that create it, comes about. And this idea had a huge impact on me and is still very, very much influencing my thought, and leads me now to the concept of the instantaneous shape of the universe, that the universe in any instant has a shape, which is actually all about the relations of its parts to each other. Its ratios, going very much back to the Greek idea that you must always talk about ratios of things which are of the same kind, not mixing up heterogeneous things. So that's been very, very big part of my thinking, and it's right at the heart of the way I'm working now with my collaborators to try and develop the alternative way we're looking at Einstein's theory of gravity.